Ethernet was invented in 1970 by Xerox and was limited to speeds of 10 megabits per second. Fast Ethernet came along at 100 megabits per second and requires Cat5 or higher copper cabling. Cat5 means Category 5. Today, most of us use gigabit Ethernet or 1000 megabits per second, uh, which also requires Cat5 or higher, but most of us use Cat6 or higher. For most of our core network devices, our network backbones, we tend to use 10 gigabit Ethernet, which will typically use fiber optic cables. We send data over the wires by sending a high or low voltage signal. The high and low voltage represents a 1 or a 0. Computers only know binary, either 0 or a 1. Everything we do can be reduced to this on or off concept. Cat5 and Cat6 use twisted pairs of wire and are the most popular cabling for local networks. Most of the time we will use unshielded twisted pair, UDP, cabling, as it is the least expensive and cheaper than the shielded twisted pair, or STP. Shielded twisted pair cabling protects the wires better from electromagnetic interference, or EMI. Shielded twisted pair is sometimes used in more industrial settings where the cabling may be needed to run near motors and machines that produce electromagnetic interference. Also, certain government and military networks may also use shielded twisted pair cabling to protect against EMI. Although today fiber optics cabling is becoming a far better choice, as fiber optics is not susceptible to EMI, is faster, and not as easy to hack as either the twisted pairs, and can cover larger distance. It is more expensive, but the price is coming down as well. So fiber optics is becoming more and more of a better option than twisted pair. But for the large, vast majority of networks, twisted pair cabling will be used. Today, most networks will use Cat6 or higher. Cat6 is capable of 10 gigabit speeds and has a plastic core to help keep the wires separated, which reduces crosstalk. Crosstalk is when the wires interfere with each other and cause corruption on the line. All twisted pair cables have a maximum distance of 100 meters, although the distance is shorter if you are wanting to do 10 gigabit speeds, and only Cat6 or higher is capable of reaching 10 gigabits. And then you have the different frequencies that they run at, right? Cat5 is at 100 megahertz, Cat5e is at 350 megahertz, Cat6 is at 250 megahertz. But as I said, majority of networks today will use Cat6 or higher. This graphic depicts Cat5e and Cat6 cables. Cat6 is the one on the far right, and you can see the plastic core in the center that helps eliminate crosstalks and keeps the wires separated. The cables are terminated with an RJ45 connector at each end. Many times the cables will be called Ethernet cables or RJ45 cables. And as you can see, there's an RJ45 connector, the yellow wire, but they all have 4 pairs of twisted wires. There's 2 wires, a solid and a striped wire. You have green, brown, orange, and blue, regardless of if it's category 5 or category 6. Right? They have 8 wires, 4 pairs in each one. Fiber optic cables are glass tubes that we send light pulses through. For fiber, a light pulse is a 1 and no pulse is a 0. Again, we use 0 or 1 on and off to build everything in computers. It's always binary, everything we do. There are 2 options for fiber. First one is single mode and the other is multi-mode. Single mode is used for long distance, high bandwidth cable runs. Think kilometers, miles, not feet or meters. It's very long distance. Multi-mode is used for short distance but high bandwidth cable runs. Multi-mode means that there are multiple beams of light at different light spectrums. The core of a multi-mode fiber is bigger to allow for the multiple beams, but the distance for which all the beams can travel is shorter. Either type of optic cable can be constructed as loose tube or tight buffered. Loose tube is for outdoor use, whereas tight buffered cables typically are used indoors. Although it is waterproof, so some have used it outdoors, it's just not as strong or as durable as a loose tube. Ethernet over power allows you to send data over the power lines in your building or home. Think your outlets. It is relatively simple and inexpensive and can run at gigabit speeds. However, you'll want to encrypt your data, which most of these devices do allow for encryption. The reason you'll want to encrypt your data is because your data will likely travel to your neighbors' homes or buildings over the same power lines, because there's nothing that stops the data from going. If you're running running Ethernet over power, it will flow to your neighbors' homes and other buildings. So you'll want to encrypt your data. Be sure to encrypt your data, right? There are many types of plugs, so make sure to check and see which ones might take up the entire outlet, right? Some will take both outlets up instead of just the one. Some will allow a pass-through outlet, so that even though you plug it into the outlet, you could plug something into the device, so you don't lose the outlet. So you're going to want to shop around and see what kind of plug it best fits your needs, and you also want to be looking for a certified adapter. Make sure it's home plug certified, and then you'll also look for various speeds, right? You want to be looking for probably gigabit or higher speeds. But yes, they will vary. I've bought some of these in the past, and it is true some of them will block both outlets, even though it doesn't look like they will. But sometimes they just are too bulky, and so you can't plug anything else into the other outlet while they're plugged in. So be very cautious about buying them, and they're not bad. A lot of times they're not as fast as they're rated as, but they beat dragging Ethernet cable across a building or home, and so they're pretty good. Now, power over Ethernet is a totally different concept, and is a great feature to have. It allows you to run just a single Ethernet cable, and thus you don't have to run electrical cables as well. This is perfect for powering security cameras and other devices that need to be installed high up or in locations that typically do not have electrical outlets nearby. You're able to send the power with the data over a single Ethernet cable. Ethernet is simple and easy to install and does not require an electrician. You can even use devices that were not designed to run with power over Ethernet by using a splitter and adapter. Here is an example. This depicts a power over Ethernet switch sending power and data over the Ethernet line, which is then plugged into a splitter. Then the extends, and the power cord, the external radio is plugged in into the wireless access point. So you have the Ethernet cable plugs into the access point, and the power cable off the splitter goes into the access point. And now the access point can be installed anywhere now that you don't need to worry about getting power to it. And that ends our discussion about cabling and Ethernet. Next up will be setup and troubleshooting networks.